Hello students, and welcome to another how-to video. Today we're going to be writing and balancing net ionic equations. This is the first video on this, and I'm going to make a subsequent video on this. And the second one, we're going to be applying understanding solubility rules. Okay, and this first one, it's going to be a little more basic to get you started. So it's kind of a step one, kind of an introduction. Okay, now we have magnesium chloride and silver nitrate are dissolved in water to form solid silver chloride and aqueous magnesium nitrate. So when we're writing this out, we're going to incorporate some new concepts into what we already know about writing equations. So let's do this. We have magnesium chloride, so MgCl, and I imagine there's going to be two chlorides on that one because we know magnesium is going to give away 2 electrons, and chlorine can only accept 1 electron, so we have to have 2 of them, okay? And it's going to form silver nitrate, AgNO3, all right? And nitrate is a polyatomic ion, okay? If you notice, it's all nonmetals, they're combining, and we have 1 metal ion. And the metal ion is going to be giving 1 electron, and nitrate only needs 1 electron, so this is balanced. And we're going to form solid silver chloride, so it's going to be AgCl, and it's going to form aqueous magnesium nitrate, and we're going to write MgNO3, and it's going to stay aqueous. All right, now let me go through and define these. This is going to be aqueous, and this is going to be aqueous. All right, now these are 2 solutions. They're clear in color. They don't have let me see if I can find a picture of it. I think I have a picture of it. Yes, right here. Let's do this. Right here. So I have in this beaker, I'm not sure which one's which. Well, however the difference, there's 2 solutions. There's one that's being dropped into the other solution, and they're mixing, and we're seeing this reaction that's occurring. And silver chloride is forming a solid while the sodium and nitrates are remaining in the solution. So these are going to be aqueous, and then this is going to form a solid. All right, now let's break this down a little bit further and write out a complete ionic equation. So we're going to have Mg plus Cl plus, because this is aqueous, essentially they're separated from each other. They're not really combining, they're separated in the solution. And the silver and the nitrate are also, well, that's not positive, that's negative. Caught myself. And Ag, silver, is going to be positive, and NO3 is going to be negative. Okay, so we have givers and takers because these are ionic bonds. Okay, silver is giving an electron to nitrate, and magnesium is giving an electron to chlorine. Okay, and when we mix them, we pour them in together, Ag, silver, is going to form a bond with chlorine. That's going to be solid. Okay, and the magnesium and the nitrate, okay, are going to remain in solution. Okay, all right. But there's one thing off from this that I haven't mentioned, and that is the equation isn't balanced. We have 2 chlorines over here, and we have 1 on this side. So let's balance this real quick before we keep going. So we've got 2 silver chlorides, and that means I've got to have 2 silver nitrates total, and then we're going to have NO3 is going to form, it's going to have 2 of those because we're going to have 2 NO3s bonding with this magnesium. Okay, I just quickly balanced this equation for you. So we have 1 magnesium, 2 chlorines, 2 chlorines, 2 silvers and 2 silvers, and we have 2 nitrates, and now we have 2 nitrates over here. So it's all balanced now, just to kind of clarify that. Now, if we look at this equation, we have things that are part of the reaction and things that are not part of the reaction. If we look, magnesium is the same on both sides. It's a spectator ion, and so is nitrate. Nitrate is negative and negative on this side. So these, we can actually cross them out because they're not actually part of the reaction. They're just spectators. They're just hanging out. They're being with everyone and watching the reaction happen. And the things that are doing the reacting is the chlorine and the silver forming a silver chloride, okay? So what's going to happen is we're going to have chlorine negative plus silver positive, okay, and they're going to come together to form AgCl. All right, and if we notice, the one chlorine is going to bond to one silver, because silver can only give one electron to chlorine, and it's going to form silver chloride, okay? And that's it for this first reaction, okay? Because this is showing you the net ionic equation. This is the complete ionic equation. We're showing everything in its aqueous form, and when it combines, silver and chlorine form a solid, and magnesium and nitrate stay in solution. Your next question should be, well, why did silver and chlorine form a solid, and why did magnesium and nitrate stay in solution? Well, that comes down to solubility rules, and that's what's on this sheet right here, okay? I've given these out in class. There are these gray papers, and it tells you the rules. And if you look here, chlorine is soluble except for when it's mixed with, oh, there it is, silver, right there. That's the solubility rule that we're noticing. And we're going to apply this more in the second video. This first one was just to get you familiar with the process of mixing two solutions together and seeing which one forms a precipitate and which ones stay in solution. Okay, thanks for watching.